good morning. Maybe you took that time to do the quiz. Maybe you took the time to study for the quiz. Doesn't matter to me. But I hope that it goes well. And like before, I'll go through and kind of, if I see an answer that should be marked correct, then and it wasn't, then I'll adjust your marks kind of accordingly. You don't need to submit your mark or your work for the quizzes, but you will need to submit your work for the test, which we have coming up next week. And I'm feeling a little bit kind of chased because we're just starting chapter 5, and I do want to do chapter 5. So I don't know, one option is we could bump it to the Tuesday, but I don't want to the 23rd, but I also don't want to throw people off because from the beginning of the term, we've been saying the 18th. So if you feel strongly one way or another, let me know either in the chat if you feel comfortable doing that, or you can text me or email me. And right, if you feel strongly either way, I will see kind of how far we get today and judge by that. I know, vague. Oh, the final exam schedule is posted. So our final exam is when? April 26th. April 26th from 6 to 9. Business math always has that 6 to 9 time slot. And the only reason for that is because there are kind of nighttime courses for this course. So then we have to accommodate that. So it's always a night exam. Okay. But usually the campus would be buzzing. Oh, did you see the final exam schedule? The final exam schedule is posted. Pretty fun. So now we know when it is. That's great. And of course it's online. And we'll talk more about that closer too. We've got bigger fish to fry right now. So just as a little bit of review, or kind of not even really review, I just kind of introduced last day, but 5.1 is introducing compound interest, right? And so what I need to remind yourself of is that all the scenarios are going to stay the same. So you deposit some amount of money and it grows to some amount, to some future value, and you know, for some amount of time. So all the scenarios stay the same, even something complicated like, remember that one big example that we went through where someone had borrowed money from someone else. So, okay, I'm going to repay you with 2 different payments, and then 2 even payments maybe, depending on the scenario. And then we had to solve for what those payments were, or what should a new repayment scheme be, right? So all those types of problems are going to follow us throughout the course now. So the only difference is that now the interest is compounded, which is going to change how we approach the calculations, but not the idea of the problems, right? So the types of problems that we introduced in chapter 4, the types of problems we introduced in chapter 4 still apply in with compound interest. With compound interest, except our calculations change slightly. Or except our formulas, I should say. Our formulas change slightly. So remembering that compound interest is at some frequency, the amount of interest is calculated and added to the principal. So for compound interest, the amount of interest earned is calculated periodically. Okay, so at some frequency, right? So is calculated periodically and added to the principal. And added to the principal. Okay. So how often we do this compounding is called our compounding frequency. So the compounding frequency is how often is the interest compounded with the principal. How often is the interest compounded with the principal? Okay. So the compounding frequency is denoted by F. So it's denoted by a lowercase f, okay, for frequency. Okay. So the compounding frequency is denoted by f. And there's going to be a few compounding frequencies that we need to know what the f is. I'm not swearing. No, so what the compounding frequency would be, right? How many times per year am I adding the interest to the principal? And so some common frequencies that we need to know, are, well, if it says it's compounded annually, well, that's once per year. So my F must be 1, right? And so the compounding frequency is how often is the interest compounded with the principal, and I should add per year. Per year. Okay. It's important. It's kind of understood, but I just want to emphasize. Okay. So if it says you're compounding annually, then your F, because we're going to use your F in the calculation, so it's important to have a good handle on these Fs. Your F is going to be 1. Semi-annually is twice per year. Twice per year. So F must be 2. Okay. Quarterly. Quarterly is 4 times per year. Okay, so that's quarterly. But it gets a little bit confusing because 4 times per year, that's every 3 months. Okay, so you'll want to keep that straight, right? So that's 4 times per year, or every 3 months. Right? I want to emphasize that because sometimes that can throw people off. So here, if it's quarterly, then your F is going to be 4. Right, so every 3 months is 4 times per year. So sometimes it'll say every 3 months, then we know that it's 4 times per year. Monthly, kind of moving down the block here, monthly is 12 times per year. Here's the one that for some reason people have a really hard time with: biweekly. Biweekly is 26 times per year, and so it's every 2 weeks. Biweekly might be the first one that you don't have, memorized already, right? Annually, semi-annually, quarterly, we know what all those are. Or hopefully, at least because you're in business, right, you have some idea of these basic periods. But so biweekly is maybe the one that's kind of a little bit off our radar. 26 times per year, right? Or every 2 weeks. Or every 2 weeks. So here your frequency is going to be 26. Okay, so just remember to commit that to memory. Biweekly, a frequency of 26. Weekly is 52 times per year. There's 52 weeks in a year. And then daily, I'll add, because it's not actually in the list in the textbook, but daily we assume is 365 times per year, right? For this course and pretty much in general, we just assume that there are 365 days in a year. So what we have is, okay, so we have this compounding frequency, and what happens is, instead of talking about the interest rate R, we're going to start talking about the periodic interest rate, right? So break up that annual interest rate R into, well, how much interest am I making in each of these periods, right? And so instead of talking about the annual or nominal interest rate R, we're going to talk about I and use I in our calculations. So instead of using R, which is still from before, it's the annual or nominal is what we can call it too, the annual or nominal interest rate. We'll highlight that this is the same as for simple interest. So it's the same R from simple interest. It's just now we need to convert it to the periodic interest rate. So instead of using R, we need to use the periodic interest rate. Which we denote by I, a lowercase I, in our calculations. And so on your formula sheet, you have that I equals R over F. And I'm gonna just block that off because we'll use it, and also because it's on your formula sheet. Okay. So the periodic interest rate is the annual interest rate, or sometimes we call it the nominal interest rate, R. And remember, we have to convert it to a decimal still, so all that's the same over the compounding frequency. So we just break it up however many times we're compounding. Let's do a little example, and I posted these this morning. maybe. So let's just do. So an investment pays a nominal interest rate of 10.8% compound quarterly. Okay, so what I want you to do is just start highlighting, okay, so here my R, right, is my nominal interest rate, which is 0.108. And then compounded quarterly tells me that my F must be 4. So what is the periodic interest rate? Find I, right, is what it's asking. Well, we have everything that we need here, of course. I equals R over F. So I is 0.108 divided by 4. I'm just going to do it on the side here because I've got adds, so that's annoying. But I get a periodic interest rate of 0.027, which means that at every quarter, I get 0.027 in interest, because overall, the whole year, I get a total of 10.8%, right? So this means that I get 2.7% per quarter, right? 2.7% per quarter. Okay. So that's my periodic interest rate. Yeah. So just like instead of talking about R, in our calculations, we use I, our periodic interest rate. So now instead of talking about time in years, we're going to start talking about time as the number of compoundings. Okay? So just like we said here, instead of using R, we need to use the periodic interest rate in our calculations. So now also, instead of using T, which is the time in years, which is still the same, right? So this T is the same as for simple interest, but now we need to manipulate it a little bit. So instead of using T, which is the time in years, and just to highlight, right, this is the same as for simple interest. Same as for simple interest. So instead of using T, we need to use N, the number of compoundings, instead in our calculations. We need to use the number of compoundings per year, or actually not even just per year, sorry, just the number of compoundings, right? Time can be more than a year, of course. So the number we need to use the number of compoundings, which we denote by N, in our calculations. So on your formula sheet, I'm just going to go grab it here. Where is it? All right. I'll bring it in once we start doing calculations here. But notice that I equals R over F is on here, and also N, which we just established is the number of compoundings, is the time times the frequency, right? So if I tell you that your investment is going to sit there for a year and a half, and it's being compounded quarterly, right? How many compoundings is that? Well, there's 4 in a year and then a half. That's going to be 6 compoundings, right? So you can simplify that by doing 1.5 times 4, and then you get to 6. So you can kind of hash it out, or what I find more reliable is just using the formula. So what we find is that N is time times the frequency. And again, I'm going to block it off because it's on your formula sheet already. Okay. So I don't actually think that I brought in an example. No, I didn't. Right, so let me see here. I didn't bring this example in, but let's do the nominal. So I'm just going to copy it out here. The nominal, and it is example 171 in case you're following along. The nominal interest rate is 9.5%, while the periodic interest rate is 2.375%. What is the compounding frequency? Hey. Okay, we're still going to solve it. It's sorry, I should have read the whole thing, or read it more carefully rather. It's still a good question, but come on. What is the compounding frequency? And how about I add a part? How many compoundings are there in 3 years? How many compoundings? Or maybe we'll step it up a notch. In 13 months. There's a pickle. I guess there should be a question mark there. Okay, so now we've got a real question on our hands here. So the nominal interest rate is 9.5%. So what that says is that, okay, well then my R must be 0.095, right? 9.5%. Well, the periodic interest rate, I, is 0.02375. Make sure you keep all those decimal places. First, we want to find what is the compounding frequency. So now just remember that I equals R over F. And so if I know I and I know R, I can easily solve for F. So I've got 0.02375 is 0.095, I think, right? Yep. Divided by F. Solving for F, right? I need to multiply this F over to the left-hand side, but then I also need to divide both sides by 0.02375. Often I'll do that in the same step. Okay, so it becomes F is 0.095 divided by 0.02375. So I have 0.095 divided by 0.02375. My F is 4, which in words, right, we remember is quarterly. Okay, so now, all right, we solved what is the compounding frequency. The compounding frequency is quarterly. So how many compoundings? So now we're solving for n in 13 months. I'm letting my time be 13 months, but 13 months is 13 out of 12 because remember t still has to be in years. So now we're going to say, okay, well, n is the time times the frequency. Right, and here I've already found that the frequency is 4, and the time is 13 over 12, right? It still has to be in years, so we're still finding time the exact same way that we did before, but what we'll find is for each chapter, we kind of level up, right? So we add a couple of things that we need to keep in mind, right? So here, it's going to be, okay, time is still the same as before, it's in years, but now I need to find the number of compoundings and use that instead. So I get 13 over 12 times 4, which 13 over 12, just do on your calculator, times 4 is roughly 4.33 repeating. Right. I'm going to, for now, because this is not a nice number, right? For now, I'm just going to leave it, okay? Usually our number of compoundings will be a little bit cleaner, but it's okay. But I'm just gonna leave it here. Talk about rounding later. Okay, so, all right. Let's see here. So what are these problems going to look like, right? We've got, we need to think about the periodic interest rate I, we need to think about the number of compoundings n, right? So our problems, however, are going to be worded very similarly to a simple interest problem, right? So our problems are still going to give information about R and T. And so as an additional first step for compound interest, you need to solve for I and N and use those in your calculations. So our problems will still only give information. So, and this is for the most part, we'll still only give information, give R and T, and F. So before we can do any calculations, we need to find I and N. So before we can do any calculations, we need to find I and N. Okay, so that's going to be your first step. So it gets a little bit confusing, but as soon as you see kind of a compounded quarterly or compounded monthly, you know you have a compound interest problem, which means, okay, my first step is to find I and N, and then I can use the formulas. So I think it's about time we bring in these formulas from your formula sheet. Oops. Helps if I bring it all in. Okay. So let's just talk about this. It's kind of a big formula sheet, right? But the reason for that is because they've saved you quite a bit of time by solving this equation for the present value PV, which for simple interest, like I said before, we for some reason just call it P, but now for all the rest of our problems, we call it PV, the present value. So here we've solved for PV. Here we've rearranged and solved for I, so you can just go ahead and use it. Here things have been rearranged and solved for N, so you can just go ahead and use it, right? And so so this original equation is the one that you need. And then if you want to, you can rearrange for PV, I, and N, or you can just go ahead and use it. So here I want to make a note that these guys are just the future value is the present value times 1 plus I to the power of n rearranged. All right, they're not new or anything. They've just saved you some work in rearranging for those. We've already talked about I is R over F and N is T times F. Okay, and so we already have a pretty good idea of this formula. How do we use this formula? And then we'll go through and we'll what I want to do is I want to do an example of solving for each of these as we go along, right? So we'll do that. But I also want to talk about these two formulas. We're going to get to them eventually, right? But here you've got changing interest rates. So this is very similar to what we saw in simple interest, right? We've already seen this changing interest rates. Changing interest rates. And then here, this one's kind of interesting and kind of a mind-blowing thing if you sit down and think about it. This is for continuously compounded investments, meaning that the interest is compounded continuously. So we can't even measure, it's not even like split seconds that it's compounding, it's continuously compounding. Which is for me kind of a hard concept to wrap my head around. But so every single moment continuously, the interest is being compounded. But we find that it's kind of a letdown, but it behaves kind of the same as all the other ones. It's not like your investment's going to blow up or anything, but it does have this special formula. So continuously compounding, right? What does that mean? F is continuous, right? There is no frequency because it's continuous. Okay, so these two last formulas, although they're taking up quite a bit of space, we just kind of leave them for last, and then we'll introduce them briefly, and then we'll move on. Okay, the main players are going to be these guys here. Okay, so what I want to do is I want to solve a problem with each of these and just kind of work through them so you've seen all of these. So if we have the future value is the present value times 1 plus I to the power of n, right? Where the FV is the future value, right, at the end of the investment, or how much are you going to owe with interest, right? So of a loan versus the present value, right? That's your initial investment. We called it the principal before, but we'll call it the present value now. I is the periodic interest rate, and n is the number of compoundings. Okay. One thing that I do want to point out is that on your timeline, so we're definitely gonna draw timelines because it's gonna help us solve these problems. But on our timelines, the length of the arrow is now gonna be n, not just t. You can have t on there, but you also have to have n. So we will use n as the length of the arrow on our timeline. Right. And just like we had R kind of floating around, same thing with I. We'll need to calculate the periodic interest rate, but it'll just kind of be off to the side somewhere. Okay. So in general, let's just map out just a general timeline Okay, I have maybe today, and here I have some vague date later. Okay, always on the left-hand side, I'm going to have the present value. The present value grows to some future value. Or if you want, right, if you have the future value and you need to think about what is that worth today, then you're calculating the other way, right? So it can go either way, but on the arrow here, you have n is the time times the frequency, right? And then I equals r over f. So you need to have all that on your timeline now. Okay. So I don't want you to not do these calculations, but probably next day. I don't think I'll have time to show you today, but because I want you to do it by hand a couple of times, but next day I'll show you how to use your calculator. So this is why we need financial calculators, because your calculator, you actually just give it all this information. You tell it what your present value is, you tell it what your n is, you tell it what your future value is, you tell it what your I is, or I think it just needs R and F, and then it does the calculations for you. So and then you just need to leave one out and it can compute that one. So I'll show you that, and then you can get to work on your calculator, and I think you'll enjoy it quite a bit. Okay, so let's do an example. And the first thing we're going to do is we're going to solve for the future value. Okay, so what I want to do is I'm just going to block it off. So I'm going to solve for the future value, give you the future value formula. We'll do an example, and then we'll solve for the present value, and we'll move through like that. So the future value is the present value times 1 plus I to the power of n. And let's see what that might look like. So, and maybe what I should do is maybe I'll highlight it or kind of block it off in pink because it is on your formula sheet, right? So there, draw our attention to it. What's the value in 10 years of a $150 deposit at a bank which earns 6.8% compounded quarterly? Now, notice the similarities between this question and a simple interest question. They're basically identical, except for now we've got this added part of compounded quarterly. So this is how I know, right? That's the only reason I know that this is a compound interest problem, right? If you just ended it here, right, and just kind of ignored the rest, well, what's the value in 10 years of a $150 deposit at a bank which earns 6.8%? You can solve that. That would be a simple interest problem, right? But most banks are compounding, okay? And so this is what makes it a compound interest question. Okay. That's going to be really important to be able to distinguish, especially on the test and on the final exam where they're all mumbo jumboed, and you're going to need to sort through. When you read through a problem, you need to sort through and say, okay, this is a simple interest problem. Okay, that's how I deal with those, right? Because it tells you what section of the formula sheet you need to be on versus, okay, this is a compound interest problem. Great, I know how to deal with those. It's a different formula, but I know how to deal with them. Right? So that's kind of the first thing you need to train your mind to do. Now, what we're given here, I'm given that t is 10 years. Okay. The present value, right, we're calling it the present value now instead of p, is $150 deposit. So we're depositing some initial amount, $150, and the rate, 6.8%, that's an annual rate. So it'll always just give the annual or the nominal rate. It'll call it either or maybe it won't say it at all. It's just implied. So the rate that you're given is always going to be R. Okay. So R is 0.068. And then finally, F is 4, right? Compounded quarterly, because so then the F is 4. Okay. If I have the frequency, then I have everything that I need to solve for n, which is the time times the frequency, and also for I, which is the rate divided by the frequency. Okay, so what I want to do is, even though this problem does not require a timeline, let's just get in the habit of drawing timelines, right? So you don't have to, you don't need a timeline for this question, but it might help to practice. Okay, so what I want to do is I want to map out what's going on here. Okay, so I've got a crooked line. So if we're starting, let's say today, then the end point would be 10 years from today, right? So here I am today, remembering things like you're putting the dates up top and the dollar amounts below. So today and then 10 years from today. Okay. I'm depositing $150. Okay. And it's going to grow to some future value. Okay. And what I want to do, instead of having just time on the arrow, right, I need to put n is the time times the frequency. And what I usually do is I just do the calculation on the arrow. I know that's a little bit sloppy, but I like to have it just on the arrow. So often I'll just do it on the arrow, or sometimes I'll just kind of calculate n and I off to the side and then bring them on, but it just kind of depends on how much space you have, really. So the time is 10 as the frequency, which is 4, which if I asked you, just kind of flat out asked you, okay, in 10 years, if I'm compounding quarterly, how many compoundings do I have? Well, you would tell me 40, right? 4 times per year for 10 years, that's 40, right? Sometimes these calculations are not that simple. So that's why I always just use the formula, right? That's the safest thing. Okay, so n is 40 and I is R over F. And just to kind of keep it nice and compact, I know I've been kind of stack your equal signs, but now I'm gonna go across, 0.068 over 4, 0.068 divided by 4 is 0.017. Kind of a 7 with a flare. There. One thing that I want to emphasize is that if I has many, many decimal places, you will need to store it. Okay. You must use all decimal places for I in your calculations. Okay. Sometimes that's more than the screen will give you, right? So you want to make sure that you store it. Okay. So you have to use all those decimal places if that's what you end up getting. Okay, here I am. My timeline is complete, right? Nice and itty bitty. Like I said, we don't actually need a timeline for this because it's just a basic calculation, but it is good to get in the habit. So now I have the future value is the present value times 1 plus I to the power of n. Notice that I've already outlined all the information that I'm about to plug in here. So for marking purposes, I can mark your whole question by what you tell me in your timeline, right? If what you're telling me makes sense in your timeline, or even if you're following through in your timeline, if you've misunderstood something and you're able to communicate it in your timeline, then I don't really care about the final answer, right? I'm assuming you're plugging it into the right equation, of course, but you should be able to show me that you know everything in your timeline. And then the answer is just the answer, right? But all the information that I need is in the timeline. So we're trying to solve for the future value of $150 times 1 plus I, which in this case is a nice 0.017 to the power of n, which is 40. Now, BEDMAS, right? So I need to do 1 plus 0.017 first. Then I need to raise it to the power of 40, right? Brackets, then exponents, and then multiplication. Okay. So this, I'm going to show that process by going 150 times 1.017 to the power of 40. So I'm just going to do it on the side here. So I had 0.017 on the screen, so I'm going to add 1. And then I'm going to raise that to the power of 40. Right? Worthwhile figuring out how to raise things to the power of whatever you want. 150 times, and you want to keep all your decimal places here, even if you don't write them all out. 1.9626285571 times 150. I get a future value of 294.39, and the page ends there, so maybe what I'll do is 3942857. Just go across. $294.39. Okay. So just trying to keep it all on one page here. So solving for the future value, done. Okay. Because the question was, what's the value in 10 years of a $150 deposit? We found that it's $294.39. You want to double check yourself, right? Because it should grow from 150. You're depositing this money. Even if you were borrowing this money, we all know that if you borrow money, you owe more than you borrowed, right? With interest. So 294.39, that's our answer. Great. How about if we have to solve for the present value? So now I'm moving across, and I encourage you to just use the formula sheet, right? We did talk about how do we use logs. We talked about exponent laws to be able to solve for these, but I'm just going to jump right in and just use them. Okay. So let's see here. Solving for the present value. Well, the present value is the future value divided by 1 plus I to the power of n. Sorry, my nose is so itchy today. Oh, bad news. Maybe. Suspect it's just allergies. It's just allergies. Okay, so if we have to solve for the present value, right, this is on your formula sheet, so I'm going to block it off here. The present value is either going to be the amount, the initial amount that you invested, or the initial amount that you borrowed, right? It can be either or, right? So let's go and grab an example. Calculate the original principal, so the original of an investment that pays $5,437.52 at maturity. So at maturity is at the end of the term, over a term of 27 months at a nominal rate of 8.5% compounded quarterly. So there it is again, and that's what I want you to train your eyes to, right? This is a compound interest question. Compound interest. Okay. So what are we given? We're given, let's just go through here. This is the future value, right? So it's gonna pay this at the end at maturity. So at the end of the 27 months. So we have we're given the future value is 5437.52. The term is 27 months. Now, here's the sneaky part, right? We're used to having to convert 27 to be 27 divided by 12 because time has to be in years. That is still the case, right? So I want you to really remember that you still have to convert it to time in years. So T is 27 divided by 12. It's more than a year, we know that, but in fact, it's more than 2 years, more than 24 months, but that's okay. The nominal rate is 8.5%, so R is 0.085, and then it's compounded quarterly, so F is 4. Hey, isn't that what we had earlier? Oh well, it doesn't matter, right? We need to know those compounding frequencies that I gave you at the beginning of the class, and then now they've both happened to be quarterly. Okay, so we want to find the present value. So I'm just going to go ahead and use the formula that we just established, right? That it's the future value over 1 plus I to the power of n. Oh, I guess, should we draw a timeline? Let's just draw a quick timeline, just for practice. There's only 2 time points today and in 27 months. I don't know the value today, so I'm trying to solve the present value. And I've got 5437.52 here as the future value. Now, this is going to get pulled back or discounted. So when we're pulling things back to a present value, we call it discounting. Okay, remembering that the length of the arrow is now n. So n is the time times the frequency, which is 27 over 12 times 4. On your calculator here, 27 divided by 12 times 4 is 9. So we have 9 compoundings. Okay. I is r over f, which is 0.085 divided by 4, which is 0.085 divided by 4, 0.02125. So now I have my timeline, right? And everything that I need is on the timeline. And now I just need to plug in these values, right? So the present value is the future value over 1 plus I to the power of n. Remembering BEDMAS still, right? I need to do 1 plus I first, then raise it to the power of n, and then divide the future value by that, right? So we need to be careful. So plugging in these numbers, 543752 divided by 1 plus 0.02125 to the power of 9. Five, 4, 3, 7, 52 divided by 1.02125, right? Adding 1 is always nice and easy, but I want to emphasize that you do need to add those two together inside the brackets before you can raise it to 9. So plus 1, and then to the power of 9. So I get 543752 divided by roughly, and you have to keep all your decimal places, 1.208338535. Okay. Must keep all decimals. Okay. You don't want to be doing any rounding at this point. So then 5437.52 divided by that is 4499.97. Oh, sorry, 997.79, which in money, again, I've come across the end of a page here. So in money, I have $4,499 and 99 cents rounds up to $1. So, and then 99, oh man. Here we go. 4,500 even. It's almost like they meant for it to go that way. So, good. Now, so that's how we solve for the present value. Now let's solve for I. Remembering that the question is not going to ask for I. It's always going to ask for R, but how do we can only get to R if we have I. So it's going to be a multi-step process for solving for R and for solving for time. Right, so it's pretty rare that it's going to ask for the periodic interest rate or the number of compoundings. Instead, it's going to ask for what is the nominal rate and is how long did the investment sit there for, right? And so solving for I, we know that I is, and I have to grab it here, is the future value over the present value to the 1 over n, or I think on the formula sheet it's got the nth root. I guess I should make sure. Oh yeah, the nth root. Okay, so let's use that first. It's got the nth root of the future value over the present value, and then minus 1, right? Notice that this minus 1 is not under the square root, which I'm going to emphasize with a little hook here. Okay. The nth root, remember, is the same as raising it to the power of 1 over n. So what we could say is, or I is the future value over the present value to the power of 1 over n, then minus 1. Notice that these two are the same. And of course, they're on your formula sheet. So actually, I think only this one's on your formula sheet. So I guess I should only block that off. I'll highlight this. You might want to add it to your formula sheet if you prefer to see the nth root as a power of 1 over n. Doesn't matter. I'll use this formula because it's what's on your formula sheet. Okay. So one thing, like I was saying, is that questions, we usually want to solve for r, right? But in order to solve for r, we need to first find I. So we usually want to solve for r, but we need to solve for I first. Right, and then remember that I is r over f. Right. So of course we'll have the frequency, so then we can easily rearrange and solve for r. Most banks, I don't see any banks report periodic interest rate or the number of compoundings. We always just talk in terms of r and t, and so that's what we would need to solve for. So let's see what does that look like. Example 178. So 15,000 was invested for 13 years until it reached a value of 30,000, right? If interest is compounded monthly, finally a different compounding frequency, what was the nominal rate of interest, right? And so here, right, this is R, the nominal rate of interest. Compounding monthly, the frequency is 12. I almost wrote 4 again. 12. Let's just, there's so much information that if I kind of draw on the question here, and maybe I shouldn't do that here. I'll just write what I'm given, a little bit cleaner if I just list them underneath. All right, so given the present value was 15,000. The time it was invested for, and I'm just doing these as I read across here. You might have nicer ways of listing it, but the time is 13 years, right? So the time has to be in years, it's 13 years. So, okay, moving on. The future value is 30,000. Interest is compounded monthly. So F is 12, right? And I'll just make a note here, monthly. Okay. And we want to find I to find R. Okay, so it's going to be a multi-step process. We can still do kind of a fake timeline here, right? Whenever we're just depositing some money and then taking it out, there's nothing really going on here. But like I said, it's good to get in the habit. So today, and then 13 years, it really doesn't matter if you did 13 years ago up to today, but I just always like to start to today if it doesn't really matter. So 15,000 was invested today and it grew to 30,000. My N is the time times the frequency, which is 13 times 12. 13 times 12 is 156. So we're talking about 156 compoundings. And then here I'm going to go I equals question mark because that's what I'm trying to solve for. Okay. Because we have the formulas, I'm just going to jump right to using the formulas. So here I is the nth root of the future value over the present value, and then minus 1. You do not want to forget this minus 1. Okay, and you'll see why in a second. But if you don't subtract the 1, it becomes 100 and some odd % per month, which is insane, right? That's not right. So that's why we need to subtract the 1. So this becomes the nth root of 30,000 divided by 15,000, then minus 1. Oh, and not just the nth root, I know what n is, it's 156. $30,000 over 15,000 is just going to get me to 2, right? So, okay, so that simplifies nicely. Divided by 15,000. Yeah. Phew. So really what I'm taking is the 156th root of 2 and then this 1. Remembering recall, and I know we did this when we were dealing with exponents, right? To calculate the 156th root of 2 on your calculator, find 2 to the power of 1 over 156. And then make sure you keep all your decimal places. 2 to the power of, and make sure that you get the same answer as me, 1 over 156. And I'm just gonna pop this over. 1.004453137. So here, if you were to just use this this whole number without subtracting 1, which I've seen a lot, right? People forget to subtract the 1. Then really what you're saying is you would need to have 100.445% per month, and that's not right, right? So then when we subtract the 100, we end up, or sorry, subtract the 1 or 100%. We get to 0.004453137. And you want to keep all your decimal places. Keep all decimal places. Right, same thing up here. Oh, maybe I should try it here. Let's use this calculator. So I've got 2, and then the y to the x button to the power of, and then because I want to have 1 over 156 all in the power, I'm going to put brackets around that. 1 divided by 156 end bracket equals. And you have to hit the equals, otherwise it'll just show 1 over 156, which is not what you want. Did that? Awesome. Good. And then you want to subtract 1. And then how about we store this in 1 just to be safe, right? Just in case we need it, which we kind of know we do because we need to solve for R. So now we know what I is, so now I need to solve for R. now we can solve for R. Right, I equals R over F. Well, and I'm just going to make a note here that I stored this in 1, right? So I is going to be that whole number 0.004453137 is R over F, which is 12 in this case. And we already solved one of these problems right at the beginning of the class. So now, or similar at least, I need to multiply the left-hand side by 12, and then I'll have R. So then R is that times 12. Oops. That's not there. I'm all over the map today. Okay. So then recall 1 times 12, 0.05343, whatever. And just to be able to have it here so I can write it down, do it on my other calculator as well. So R becomes 0.053764441. Right. Therefore, the nominal rate of interest is approximately 5.34%, which is the answer to the original question that we wanted to answer, right? How much per year are we paying, or is it paying? As a side note, right, in Moodle, I noticed that it doesn't really specify how many decimal places. Just as a rule of thumb, 2 decimal places is good, right? So if you feel the need to go for more, then that's fine, right? Give the answer to 2 or more decimal places. Just as a general rule of thumb. Good. Okay. So we've solved for the future value, we've solved for the present value, we've solved a problem where we had to solve for R. Oh yeah, which part? We have to endure this top 4 at, I don't know what that is. Sorry guys. Oh, you want the 156th root of 2. So you have to have your base on the screen, so 2, and then hit the y to the power of x button. It's above the 9. So here I'm holding it down, but I want to make sure that it does it. Okay, let me just clear out here. 2 to the power of, and then I want to raise it to the power of 1 over 156. So I want to keep that all in brackets. So if you do bracket 1 divided by 156, end bracket, just be careful because it actually doesn't do anything unless you tell it to. So here it's just showing 1 over 156, which is not the answer. So you have to hit equals, and then you get to the answer. So in some ways, this calculator is really, really handy, and in some ways, it's a really bad calculator, right? It doesn't do anything unless you tell it to. So usually hitting the equal sign is what you want to do. Nice, good. All right. Okay. I'll stick to my scheme of having fresh pages for each of these. The last thing we want to do today is solving for n. From your formula sheet, right, n is the natural log of the future value divided by the present value divided by the natural log of 1 plus I. And that's on your formula sheet, and pretty sure there's no other way to write it, so I'm feeling confident that that's what it looks like. Again, right, usually the question isn't going to ask us to solve for the number of compoundings. It's going to ask us, how long did you make this investment for, right? And so usually the question will ask us to solve for time, right? But we need to solve for n before we can solve for time. So usually the question will ask us to solve for time, but we need to solve for n and then use the fact that n is t times f. But we will first need to solve for n. We first need to solve for n and then use n is t times f to solve for time. Okay. So solving for r and t, just like when we were given information about that, we had to convert it, right, to I and n. So now we need to convert it back. All right, so let's see here. What's our next example? 179. So it says, in order to save for college, you want to invest $10,000, just have it laying around, you know, and have it grow to $15,000. Okay, so we have the present value, we have the future value. If the rate of interest is 8%, so we have R compounded semi-annually, how long will it take for this to occur, right? So we're not going to want to talk about how long in the number of compoundings, we want to talk about in time, right? So here, let's just list the things that we are given. I'm given the present value is 10,000. I'm given the future value is 15,000. Oops. Just kind of reading along here, jotting down any information that I'm given. R is 0.08 and F is semi-annually, so 2, right? Semi-annually means twice a year. So semi-annually. And we want to find time. Find n to find time. Okay. So we have this formula for n, even though it involves these natural logs, we know how to deal with those, right? We dealt with logs earlier, and this is why. So let's just jot down a quick timeline, right? Get an idea of what's going on here. So let's say that today I'm making this investment, and then I'm actually trying to solve for this endpoint here. But I do know that 10,000 has time to grow to 15,000. And n is also unknown. And I is r over f, which is 0.08 divided by 2, which is 0.04. So we have all the information that we need, but we need to solve for n. So let's do it. So n is the natural log of the future value over the present value over the natural log of 1 plus I. And we already developed this formula, but that was back when we were working with logs. And I said, hey, here's a scenario where we actually would need to be able to solve for n. But now we just use it. It's the natural log of 15,000 divided by 10,000 divided by the natural log of 1 plus 0.04. I always just confirm 15,000 divided by 10,000 is 1.5. So what I've got is I've got the natural log of 1.5 over the natural log of 1.04. Now, remember to do the log of 1.5 on your calculator. You have to have 1.5 on the screen first and then hit the LN button. So we did practice doing these calculations earlier when we were talking about logs. So on your calculator, the log of 1.5 on your calculator, you have to have 1.5 on the screen and then hit the LN button. And then you might have to hit equals, or I usually just hit equals just in case, right? And I think what we landed on, you guys were testing it out, I think you can just go ahead and do this calculation all in one go. Or if you prefer to find the log of 1.5 and then find the log of 1.04 and then divide them, that's safe, right? It's a little bit more work maybe, but so I'll do it on this calculator here. So I've got 1.5 and I want to take the natural log of it, so I have to hit the LN button. I'm hitting the equals just in case, but nothing's happening. So I'm going to store that in 1. Why not? And then I also want to find the log of 1.04. 1.04 on the screen, and then hit the LN button, equals. I'm going to store that in 2. And then just to play it safe, and then I want to test doing it all in one go, but I think we landed on you can do it all in one go. But so what I want is I want recall 1 divided by recall 2, 10.338. Yeah. So let's see here. I'm going to jot this down. So I get, and I'll just do it over on this side here. Oops. 0.4054651081. Keep getting my calculators mixed up. All the buttons are in different places. 0.03922071315. So then the log of 1.5 divided by the log of 1.04. I do end up at that same answer, 10.33803,507. Now let's just try it. Let's see here on your calculator. So we wanted to do 1.5 ln divided by 1.04 ln equals, works out just fine, right? So you can play around with it, and then when you're comfortable that you get to the same answer, then you can start using quicker ways. But right? As long as you find that you are at 10.338, okay, then you're good. This is our n, right? So here, let's just say, so n is approximately 10.34. But that's 10.34 compoundings. I don't think you'll find a bank that will let you go to 0.34 compoundings, right? And so they'll say, oh no, you'll have to kind of go for a full compounding. They would let you go for a partial compounding, but just to be safe, right? How long will this actually take? We're going to assume that you have to go for a full compounding, right? So we can't, and we've seen this before, right? Where we can't have, we can't produce half a unit, right? And so same thing here. We can't go for 0.34 of a compounding. Can't go for 0.34 of a compounding. That's kind of just an assumption that we're making here. So we always round up for n, right? 10.34 actually becomes 11 compoundings. So n is going to be 11. So just take a moment and just kind of convince yourself, oh, okay, yeah, that makes sense. So now n is time times the frequency. I'm trying to solve for time. I know n is 11. T is what I'm solving for. And I can't remember what the frequency was. 2, semi-annually. Oh, just catching up here. Down to the wire. So T is 11 over 2, but 11 over 2 is a fraction, and that's okay. Weird, right? Because T can be 5.5 years. Okay. Good. All right. So 5.5 years, that's how long you would need to have this investment sit there for. Now, instead of talking about doubling time, although it's just like a fun exercise and just really useful to have, I'll save it for next day. Make sure you read the rest of chapter 5 so it's not such a doozy next day. Yeah, we'll finish chapter 5 next day. If you have any questions, let me know. If not, have a great weekend. I'll see you on Tuesday.